Our Raceway and Cable Management Design tool is used for 3D cable tray, conduit layouts, and rules-based cable routing. The conceptual design functions can be easily used early on for front-end engineering, allowing the user to reserve physical space for electrical trays and conduit. Preliminary cable lengths can also be generated and used with the wire sizing and sustainability function found in our electrical design tool. The detailed design functions allow the user to fully detail cable tray and automatically route cables. That's what we're going to focus on in this demonstration. So to start out with, we're going to route some cable tray. Cable tray and conduit can be easily placed using the Raceway router. So in here, you can select from a different list of manufacturers and different conduit types. You also have the ability to route more than one Raceway or conduit at a time. And this can be done by applying or specifying the appropriate vertical and horizontal offsets by using the add function. So that would be if you wanted to route a group of conduits or a group of Raceway all at once. We also can apply various parameters. So parameters such as rules can be applied to the Raceway, meaning voltage levels. So if we look at the properties, you can see that we can assign a voltage level. Dividers can also be applied. And from the selection list, you can choose the number of dividers you wish to use. And again, that voltage level can be applied for each divider. You can also specify the maximum capacity or maximum fill capacity for each section or divider in the Raceway. In this demonstration, we're just going to simply route a simple Raceway. Now, I have already referenced in our plant design models generated from our other design tools. So I'm going to go begin and route the Raceway. I'm going to start by defining a start point for the Raceway. We'll pick that point, and then we'll just continue drawing out our Raceway, maybe in the X direction, 3 meters, for example. I can also insert various parts. So for example, I can use the place part function, and I can pick vertical bends or standard bends. In this case, I'm going to pick a vertical bend with a bend radius of 90, and we're going to angle at 45. Again, I'll place another 45-degree bend. And continue routing this and place another part. We also have the ability to generate a downward bend, and in this case I'm going to say 90 degrees. Now we'll pick another part. In the top view, we want to do a 90-degree bend left. And I'll just pick that from the list. I can place that wherever I need to. And now I'll go ahead and run that Raceway all the way to the end of the structure. We also have the ability to insert parts. So for example, maybe in this Raceway that we just placed here, we would like to insert a T. So in this case, on this section is where we want to insert that T. So using the insert part function, I can select the Raceway that I want to insert the part to. Now I can choose what type of component or what Raceway part I would like to insert. So in this case, again, I'm going to select a T. And I can choose left or right or both directions. In this case, let's say left. So you can see how it brings in that T for me, and I can place that down. I can continue routing by simply just using the Raceway router using the connect function. So I can pick that, and I can drag that to wherever I need to. Next, we're going to open up the electrical equipment model. I'm going to zoom in on the isometric view. The small green boxes represent the equipment termination areas. Each piece of equipment, as you can see here, is tagged using the equipment placement functions. In this example, this is 01 PBS 3101 is the tag for this specific push-button station. Cable lists from both our electrical and instrumentation design tools can be imported. So I'm selecting the electrical cable list and importing that. Now I'll import the instrumentation cables. Users also have the ability to import what we call an equipment map. The equipment map can be used to add additional cable lengths to each piece of equipment. To do that, the user can go into the ID manager. Note how the distance column currently does not contain any values. I will select the import map file and its configuration file to complete the import. As you can see, the distance column has been automatically populated. Now, let's take a look at the detailed raceway layout. I'll zoom in on the isometric view. As you can see here, the cable trays and conduits have been previously routed using the raceway router. For example, you can see here is a conduit as well as a couple trays. You can also take a look from a top view as well. Next, we're going to go into cable routing. So I'm going to open up the cable routing model. The data from the imported cable lists will now be used for the cable routing. To do this, I'm going to open up our cable manager. We'll use the Auto Connect function. The Auto Connect simply routes the cable the shortest way, ignoring any raceway rules. This just establishes the logical connection between the source and the targets. In this case, I'm going to update the length as well. As you can see here, I have a direct length listed. The selected cables will automatically be routed and a new cable length will be determined. As you can see here, each cable is getting processed. Also note how the routing manager flags any unrouted cables. A common reason for cables not being routed could be that there is too much of an air gap between the equipment and the raceway or conduit. Settings can be applied to adjust the allowable air gap. Now we're going to update the length and actually populate the true 3D routed length. As you can see here, it updated the length. Note how the tool records all the raceway IDs a particular cable is going through. So after it's routed, it has a complete route showing what conduits and what raceways each cable is routed through. The cable manager automatically generated the routing model. This routing model can be used to quickly determine potential raceways approaching their fill limits. To do this, I'm going to refresh the routing model with the routing data. The routing model has been updated. Yellow indicates raceways that are approaching their maximum fill allowance. Red would indicate an overfill situation. We can also look at the fill properties. For example, let's take a look at this raceway here that's highlighted in yellow. The instrumentation section of this raceway, I and W, is approaching its maximum fill. The fill for this section is about 67%, 32.8% spare. In a situation like this, raceways can be easily resized in the raceway model using the resizing tool. This tool will automatically update the 3D model with the new raceway selection. We also have the ability to generate cable drum reports. So I'll go back into Cable Manager. And in here, we can select cable drum from the list, or cable drums. Cable drum reports are easily generated for construction. The report will display the cables tags associated to each drum and cable type. Note the drum sizes are user definable. So here's the length of the cables showing their association to which drum. And again, the drum size or max length on a specific drum is user definable. 2D extractions can be automatically generated. So let's take a look at that. Let me open up my 2D extraction file. And this is just a reference of the actual raceway model brought into a title block. So first off, we have a section plane here. And this has been previously placed. So we're going to add some cable charts over here, or section charts. We can do that by using the extraction tools. Here you can choose what type of extraction table you wish to display. In this case, I'm going to do accumulated cable info. And I'll place that chart down on the drawing. And we'll zoom up on it here. You can see the cable type is listed, as well as the raceway categories and various information. If you're looking for a more detailed report, or section view, you can choose the detailed cable info and graphics. In this example, it gives us all the cable tags, cable types, as well as the cable size, and even the weight of the cables for each section of raceway. Additional reports can be generated using the Output Manager. We'll do a bill of quantity. I can choose what files I wish to do a bill of quantity on. Let's say the equipment file, as well as my master raceway model. All of these reports can be sent directly to Excel or saved in Excel format. So here you can see how it's keeping track of the various quantities. We can also generate raceway schedules. So I'll go back into Output Manager, and we'll do a raceway cable schedule. And we'll generate that from the raceway routing model. In this case, you can see all the raceway IDs listed, as well as the raceway length, the cable type, cable IDs, and cable weight. Many other reports can also be generated and stored in Excel. In review, here are the raceway and cable routing design benefits. What we saw in the demo was flexible 3D raceway routing tools. We also saw rules-based cable routing, as well as raceway fill tracking, automatic 2D extractions. We saw that the cable length was automatically calculated when we routed the cables through the raceways. And also, various reports can be generated, such as the cable reports, drum reports, and raceway schedules.